Right, this is called solving quadratics. Now that word quadratics, you've heard it before. You either see a quadratic written in two brackets like that, or you would also see a quadratic written some x squares plus a number, or so, plus some x's plus a number, right? So both those equations are quadratics. Now you could only solve a quadratic if it has an equal sign, and the equal sign on the right hand side always has to have 0. Otherwise you can't actually solve a quadratic. If I remind you of what a quadratic looks like in terms of the graph, anyone know? If you have y equals x squared, what sort of shape have you got? Y equals x is a straight line, y equals x squared is a, starting with p. Parabola or parabola? The same, they mean the same thing.
Parabola.
Okay, and here's a quick picture of what a parabola looks like. It's a curve. This is the x-axis, this is the y-axis. It cuts the axis at two places. If you're aiming at excellence, you need to be aware of this. And in this instance, the x-intercepts happen to be at -9 and +8. Okay. Now, the two solutions for this parabola happen to be +8 and -9. Okay, those are the two solutions for the equation and happen to be where the graph cuts the x-axis. Now, if you're not interested in excellence, you wouldn't need to know that, but you do need to be aware, if you're aiming at excellence, that what that graph represents is a curve, and it does cut, where it cuts the x-axis are the two solutions. So in other words, for a parabola, for a quadratic, there's either two solutions. If I drew an equation that just touches the line there's only one solution. Or if I drew a parabola that didn't touch the x-axis at all, there are no solutions. Anyway, coming back to solving x minus 8 and x plus 9 equals 0. The two solutions come from x minus 8 has to equal 0 and x plus 9 has to equal 0. Okay? Don't forget, if you could make one of these brackets 0, then 0 times whatever you like in that bracket is going to equal 0. 0 times something is 0. Hence, if I made that bracket 0 from this equation, 0 times whatever happens in this bracket will give 0. So the two solutions come from this equation and this equation. If I solve this equation, I'm going to add 8 to both sides, just like I normally would, and x is going to equal 8, one solution. Giving one solution in a quadratic will not gain you an achieved mark. You have to give both solutions. In this equation, x plus 9 equal to 0. I'm going to take away 9 from both sides because I'm undoing a plus. The 9's cancel, and I'm going to be left with x equals -9. Both solutions to get one achieved mark. I'm recording this, so this goes up on the Weebly, so come September you could watch this video and remember what to do. Jumping down to question 23, can you see where I'm pointing? Question 23. X plus 3, no, x minus 3 rather, that all equals 0. This is question 23, right? It is a quadratic, still a quadratic, just be aware of that. It is a quadratic because when I multiply it out, and I wouldn't do this to solve it, but I'm just showing you, x times x, x squared, minus 3x. Now there's some x squares in it. As soon as there's some x squares in it, it becomes a quadratic. Still equal to 0. Because it's a quadratic, I know there are two solutions. One of the solutions will come from x minus 3 being equal to 0. And if I add 3 to both sides, do this quickly, I get x equals 3. So one solution is x equals 3. What do we think the other solution is going to be? Daniel, say it louder.
X equals 0.
And you're right. The other solution would be x equals 0, and that comes from putting 0 on the outside of the bracket here. Okay? X equals to 0. Whatever happens inside of the bracket doesn't really matter, because 0 times whatever happens still becomes 0. And yes, x does equal 0. Now, referring back to my little sketch, that means it cuts at 0 and positive 3. Right? 0 and positive 3. That's where the solutions come from, the graph. What happens if I look at question 35? 35, are you with me? Question 35 is 8 minus 3x. New bracket, 8 plus 3x. Whole thing has to equal to 0. Two solutions. One comes from 8 minus 3x equal to 0. One comes from 8 plus 3x equals 0. Okay? First one, trying to get x by itself. I'm going to first of all take away 8 from both sides. 8's cancel. I'm left with minus 3x equals minus 8. Last step, divide both sides by minus 3. Okay, divide by minus 3 both sides. I'm left with x equals 8 over 3. I've got rid of both the minuses. That's one solution. The other solution comes from subtracting 8 from both sides, then dividing by 3 both sides. X equals minus 8 over 3 and positive 8 over 3. Two solutions. So again, if I drew that sketch, 8 over 3, that's 2 and a third, isn't it? Or 2 and 2/3 rather. Here's 2 and 2/3. Here's minus 2 and 2/3. It's a parabola that is symmetrical. Ignore the picture if, yeah, but it's just nice to know what you're actually doing, right? Okay. But that's the important bit there. Getting 8 and 8 over 3 and minus 8 over 3.